All right, so this is the example video for 1.4. Number 8, if you're reading the textbook, it's asking you which of the problems you would have to go ahead and square twice. And so the answer is C. So whenever you have two radicals, you're going to have to do it twice. And so just be aware of that. A, you just square both sides, get rid of the radical. B, you can actually do substitution for that one. And then D is the same thing. You just square it at one time and then you be good to go. But since C has two of them, you're going to have to do it twice. And we'll do a couple of examples like that. So now we're going to go ahead and move on to number 11. So number 11 says that the square root of 3t plus 4 is equal to negative 6. Now the principal square root is never negative. So therefore, this equation has no real solutions. Now the other thing is that this is the square root, and so if the index is even, it has to be positive in order for it to be a real number. Now that is a little bit different than number 15. So number 15, we have the fifth root of x squared plus 2x it's equal to negative 1. And so here what we do is this can actually be negative because the index is odd. So what we're going to do with this is we're going to raise each side to the fifth power. And so what that does for us is gets rid of the radical. And then so therefore x squared plus 2x is equal to negative 1. So now we have a quadratic. I'm going to move the 1 over to the other side. And then we're going to go ahead and factor this. Now, this is a perfect square trinomial. X squared is a perfect square, 1 is a perfect square. And then 2x is equal to 2 times 1 times x. So then the way that we're going to do this is going to be x plus 1 to the second power is equal to 0. If we take the square root of both sides to get rid of that square, right, I'm going to go ahead and just put plus or minus 0, although 0 is neither positive nor negative. So then here, the solution to this particular one is x is equal to negative 1. Now, it does work. So if we were to check it, I might just do it here real quick. So negative 1 squared plus 2 times negative 1. So it's going to be 1 minus 2. So it's going to be the fifth root of negative 1, which is equal to negative 1. So that's a true statement. Always check. All right, I probably won't check them all just for the sake of time, but always double check all of your work to make sure that the solution that you got is actually the solution to it. So number 17, what we're going to do is we're going to square both sides. So this is going to be x squared is equal to 64x. So just remember that if I square the square root of x, I end up with x. The reason being is that I can rewrite this as x to the 1/2, and then if I do this, I get x raised to the 2 over 2, which is x to the first power, which is just equal to x. So here we're going to move the 64x over to the left side. We're going to factor out an x. And so here we got x is equal to 0 and x is equal to 64. And so here, real quick, let me write the solution set for this one. So both of these work, or both of these are a solution. So then the solution set is 0, 64. So now number 24, we have this one here. And so just like we did previously, we're going to go ahead and square both sides. So we end up with 3 minus x plus x squared. And then on the right side, we're going to end up with x squared minus 4x plus 4. So we're going to go ahead and combine like terms. I'm going to subtract the x squared from both sides. So 3 minus x is equal to negative 4x plus 4. I'm going to add the 4x to both sides. So 3 plus 3x is equal to 4. Subtract the 3 from both sides, so I get 3x is equal to 1, and then so x is equal to 1/3. And so if we were to check it, it works. And so actually, when we check it, what we end up with a negative. We end up with negative. Let me check it over here real quick. So square root of 3 minus 1/3 plus 1/3 squared is equal to 1/3 minus 2 squared. So what happens here is that we end up with 3 minus 1/3, sorry. Plus 1/9 is equal to negative 5/3. So this is no solution because square root of an expression cannot be negative. All right, the next one that we have is number 28. And so just like we did previously, so before we do this, what I'm going to do is I'm going to move the 3 over to the other side, so it becomes x plus 5. Let me do this here. Square root of 1 minus x is equal to x plus 5. And then we're going to square both sides again, so I get 1 minus x. And here we're going to get x squared plus 10x plus 25. We're going to add the x to both sides. So I get x squared plus 11x plus 25. Then I'm going to add the 1, and subtract the 1, sorry. So if we were to factor this, we end up with x plus 3 and x plus 8. So we get x is equal to negative 3 and x is equal to negative 8. Now, if we were to check this, we get 1 minus negative 3. Minus 3 is equal to negative 3 plus 2, which is negative 1. So 1 plus 3 minus 3, so the square root of 4. So the square root of 4 is 2. And so we get negative 1 is equal to negative 1. So this one works. The negative 3 works. Now we can check the 8, or the negative 8. When we check the negative 8, I'm just going to go ahead and skip that one step. So it's negative 8 plus 2, which is negative 6. Square root of 9 minus 3. So 3 minus 3 is actually to 0. This is a false statement. So the only solution set for number 28 is negative 3. Now, number 30 is the first time that we come across two radicals. And so one of the things that you want to do when you have two radicals, like I said before, is you're going to have to square both sides. So one of the things that you want to do is you want to move one of the radicals over to the other side. So we get 1 minus square root of x plus 2. So when we squared both sides, we get 3x plus 7. Now, on the right side, you're going to have to FOIL this. And when you FOIL this, you end up with 1 minus 2 times square root of x plus 2 plus x plus 2. And then so you're going to go ahead and combine like terms. And so 1 plus 2 is going to be 3 plus x minus 2 square roots of x plus 2. So I'm going to go ahead and subtract the 3 from both sides, which will, in this case here, will give me 4. Then I'm going to subtract the x from both sides. Now, at this point in time, we can divide both sides by negative 2. So it's going to be negative x minus 2. And then, of course, we're going to go ahead and square both sides. This is the second time that we did this. So then here we're going to end up with is x squared plus 4x plus 4 is equal to x plus 2. Combine like terms, so it's going to be x squared plus 3x plus 2 is equal to 0. That's going to factor out to x plus 1, x plus 2. So that means that x is equal to -1 or x is equal to -2 or both. And so when you check these, you're going to find out that -1 is extraneous, so it's not going to solve it, and I'm going to show you here. Right, so if I were to plug in -1, so we get -3 plus 7 is equal to 1 minus 1, right? Square root of 1. Square root of 4, 1 minus 1, so 2 is equal to 0, and that's a false statement. And then, so -2 actually does work, and so the solution here is -2. All right, so number 40, they rewrote it a little differently, but I showed you what anything raised to the 1/2 is equivalent to the square root. And so if I just go ahead and square both sides, I end up with x squared minus 16 is equal to 81. And so I'm going to add 16 to both sides, and I get x squared is equal to 97. So x is equal to plus or minus square root of 97. And so when we check these, we end up that they both work. So the solution set is negative square root of 97 and the square root of 97 for both of these. And that's the solution for number 40. The next one is number 43. So for number 43, if we were to square it the way it is, we'll end up with x squared minus 4, and then x squared minus 1 is equal to 0. So what we do here is you can get factors of x to the 4th, which is just x squared and x squared. And of course, you can also, you can't do, so if I do x squared times x squared, I guess x to the 4th. And so I can also do x to the 4th times x, right? So if I were to do those and I add them, this one would actually give me x to the 5th power. So the one that we can use is just x to the x squared and x squared. Now factors of 4 is 1 and 4, and then 2 and 2, right? And so what you do is you just try different combinations, just like you do a regular quadratic equation. And when you do that, you end up with x squared minus 4, x squared minus 1. So we have x squared minus 4 is equal to 0, x squared minus 1 is equal to 0, x squared is equal to 4, and x is equal to plus or minus 2, because I take the square root of both sides. And then here I get x is equal to plus or minus 1. So all of these actually work in this one. So the solution set would be -2, -1, 1, and 2 for number 43. All right, number 46 is similar to the previous one, the one that we just finished doing. And so we're going to go ahead and factor it the same way. And so for this one, when we factor it, we actually end up with 2x squared plus 3, and then x squared minus 4 is equal to 0. So if you were to FOIL this, you would end up with 2x to the 4th minus 5x squared minus 12. You can also do substitution if you feel comfortable, and I think I will show that in one of the next problems, so next 1 or 2 problems. So in here we get 2x squared plus 3 is equal to 0, x squared minus 4 is equal to 0. Now, x squared minus 4 is a perfect square, the difference of squares. So it's x minus 2, x plus 2, and this is where we get the x is equal to plus or minus 2. So for this one, we get x squared is equal to -3/2. And so obviously this is not a real number. So then the only solution set for this one is plus or minus 2 for number 46. Now, number 49 is one where you can do it one of two ways. You can do substitution or you can multiply everything out. Either way, you're going to get the answer. But if I let x equal to u equal to x plus 2, I can rewrite this as u squared minus 7u is, plus 12 is equal to 0. And so when we do that, we get a fairly straightforward quadratic equation, which we know how to solve or factor. So here, in this case here, at this point, we're going to say, okay, so u plus 3 is equal to 0, u plus 4 is equal to 0. So u is equal to negative 3, and u is equal to 4, negative 4. Now, since we did the substitution here, we're going to replace u with x plus 2. And so we get x is equal to negative 5, and x is equal to negative 6. They both work. So then we end up with negative 6 and 5 for number 49. Number 51 is similar. So here what we're going to do is we're going to let u is equal to 3x plus 4, which equals to u squared minus 6u plus 9 is equal to 0. So u squared minus 6u plus 9 is a perfect square trinomial, which means that we can factor it as u minus 3 to the second power. So remember, if I do u minus 3 times u minus 3, I get u squared minus 6u plus 9. So it's a perfect square trinomial. So I find the square root of both sides. That's minus 3. So I get u minus 3 is equal to 0, and I get that u is equal to 3. So now, since u is equal to 3, I'm going to replace u with 3x plus 4. I'm going to back substitute. So 3 minus 4 is negative 1. X is equal to negative 1/3. Sorry about that. Doesn't want to cooperate. And so this one works if I double check it. And I get that, oops, sorry, let me rewrite that. So x is equal to negative 1/3. So for number 57, what we're going to do here again is we're going to let u equal the square root of x, which means that u squared is equal to x. So then u squared plus u is equal to 20. U squared plus u minus 20 is equal to 0. And this one's fairly straightforward to factor. So it's going to be u plus 5, u minus 4 is equal to 0. So u plus 5 is equal to 0, u minus 4 is equal to 0. So we know that u is the square root of x, so it's going to be the square root of x plus 5 is equal to 0. Square root of x minus 4 is equal to 0. And so square root of x is equal to negative 5. It's not real. Square root of x is equal to 4. If I square both sides, I get x is equal to 16. And so the only solution to this one is when x is equal to 16. All right, the next one is number 63. And so for number 63, we're going to raise both sides to the fourth power. So we get 5x squared minus 6 is equal to x to the fourth power. I'm going to move everything to the right side. And so here again, we can go ahead and substitute this now. So u is equal to x squared, which means that u squared is equal to x to the fourth power. So equal to 0 is equal to u squared minus 5u plus 6. And so here we have a fairly straightforward one that we can factor. So it's going to be u minus 3, u minus 2. So u minus 3 is equal to 0. U minus 2 is equal to 0. U is equal to x squared. So we're going to do this. We're going to back substitute. Right? And so now we can go ahead and solve these two. So that means that x squared is equal to 3, so x is equal to plus or minus the square root of 3. Same thing here, so x is equal to plus or minus square root of 2. And so what happens here is that negative square root of 3 and negative square root of 2 are not solutions, so we only have square root of 2, square root of 3 as the solution set. So just make sure you double check and you'll see that those won't work. All right, the next one is number 65. And number 65, what we're going to do is we're going to say we're going to let u equal square root of x squared plus 3x, which means that u squared is equal to x squared plus 3x, right? And so when we do that, we end up with u squared plus u is equal to 6, which means that u squared plus u minus 6 is equal to 0. And then we can factor that into u plus 3. U plus 2 is equal to 0, which means that u is equal to negative 3 and u is equal to negative 2. Actually, this is a minus, sorry. U minus 2 is equal to 0. So this means that u is equal to 2. And so once we double check those for number 65, we get that square root of x squared plus 3x is equal to negative 6. So this is not real, so there's no solution. And then the square root of 3x, x squared plus 3x is equal to 2. So in this case, we square both sides. So it's going to be x squared plus 3x is equal to 4, right? You square both sides to get rid of the radical. And then it's x squared plus 3x minus 4 is equal to 0. And so when we factor this, we get x plus 4, x minus 1 is equal to 0. And so we get x is equal to negative 4, x is equal to 1. And so they both work when you check them. So the solution set would be x is equal to negative 4 and x is equal to 1. And that's the end of 1.4. Thank you.